Hi, my name is Tom Heraly. I'm with Milwaukee Area Technical College. So for me to transport a part from robot to robot would require some kind of conveyance system. In the old days, it would have been a conveyor. Conveyance systems are now becoming autonomous mobile robots, or actually automatic guided vehicles in the past, AGVs. The AMRs are these much more intelligent automatic guided vehicles, and that they actually have the ability to reroute themselves. And that's the cool part about the AMRs. Not only can they reroute themselves, but they can actually talk to the other AMRs to identify where they are to avoid each other. These really have become, I think, are going to become the next conveyance systems. OTTO, first time I saw them was on IMTS show almost 10 years ago, but OTTO was on the ground floor. And what's really interesting about the OTTO is not so much the vehicle, but actually their mapping system. And that is what I'm looking at, is what do you have in place for me so that I am not creating my own mapping system. And OTTO just has this fantastic mapping system that makes it easy to program it from one point to another. I went with 5 of them. 4 of them I wanted in with the students, and the 5th one as either a demo unit for marketing or a unit that could be modified operationally. So in this space that I have, I can manipulate easily 3 Macs. So what I do is take and open up the doors and send them down the hall. And what that does is it opens up the space. It also kind of simulates the environment that you would have in manufacturing. The hallway allows me to put in traffic lanes, and to then integrate that with pedestrians. And even at night, I leave them on to show what a lights out manufacturing facility would look like. This is another tool in the classroom. We're going to start off kind of where the program is pre-programmed. We'll have spots that pick up and drop off, and then we'll manipulate those. They're going to implement a integration of those AMRs to the robotic systems and the PLC systems. Later on, as we mature and get better at it, then we're going to open that up so that the students can modify where they're stopping, where the docking stations are, and some of those traffic control situations, like can you set up some lanes of traffic? Can you put stops in there? Can you actually put in a new docking station and have the robot go to that docking station? But it's kind of like a robot. You start out where the robot's pre-programmed, you just integrate, and then the students go, well, I want to program the robot. Then they go and do it, And that's the same I think we're going to see with the AMRs. The demand is through the roof. I cannot provide enough students, and I don't think Southeastern Wisconsin can provide enough students to the manufacturers that are requiring this integration type of activity. There are examples, cheese plants going fully automated. We have agricultural manufacturers going fully automated. One of them actually is incorporating the OTTO AMRs in their manufacturing facilities. We need to have students that actually can manipulate them and work on the AVRs, but do the integration. It's all about that integration of software, mechanical systems, electrical systems, hardware, all of that. And so you need to have a student that really can kind of dive into any one of those pillars of information and understand that and push it up. This market's going to explode once they figure out that that integration technology is there and that we can integrate this into everyday life. At some point, it's going to become technicians taking care of all of this.